Hello everyone, welcome to our YouTube channel. My name is Sachin. In this video, we are going to discuss about the volumes in AKS. So let's start. First, we will understand the status application. So stateless apps do not store any session or user-specific data between requests. Each request from a client is handled independently, and the server does not maintain any information about the previous request. So let's suppose you have a pod running and it does not have any storage associated with it. So and you uploaded some things to your pod. If the pod restarts after some time, then that particular thing will get lost. Okay, you cannot retrieve it. So it will not store any session data between requests. But on the other hand, it makes it easier to scale horizontally by adding more servers to handle increased traffic. So yeah, it is basically very easy to scale it because it does not contain any related resources, right? In AKS, stateless applications are typically deployed as Kubernetes pods without any persistent storage. These applications rely on external data sources. Yeah, you can add other data sources to your stateless applications, but for the long time, it is not considered, it is not recommended to use it, um, because um, it may result in the loss of data. Right? Stateful apps, on the other hand, stateful apps are um, just opposite to the stateless apps. They store session or user specific data between requests. The server maintains information about the client's state. Stateful apps requires additional resource to manage and store the data, and they can be more challenging to scale horizontally. Right? Stateful applications in a case requires persistent storage to maintain data between restarts. So yeah, if you attach certain storage to your pod, then it becomes stateful apps. So if a pod is attached to a volume, and if your pod restarts or if a pod dies, then your data will be intact in that storage, and it can be reused again when you create another pod and attach it to the same storage, same persistent volume. So in that way, you can use your stateful apps. Although in Kubernetes, you there is a specific resource designed for managing stateful applications that is called stateful sets. You have a specific YAML for that stateful set, and you can use it um, if you want to store persistent, if you want to store data, right? So that has replica sets as well. So you can use stateful sets specifically for the persistent storage. Now, persistent volume. In AKS, a persistent volume is a Kubernetes resource that represents a piece of persistent storage in the cluster that can be used by pods. So you can use persistent volume for storage provisioning, and it can provision solutions provided by Azure, such as Azure Disk, Azure Files, or Azure Blob Storage. So what is like persistent volume is nothing but uh, volume that is getting used from the Azure itself. What kind of volume? It can be Azure Disk or Azure File or Azure Blob Storage. It depends on you actually which type of volume you want. So and where it will reside? It will reside on the node, AKS nodes. So if a pod is dead and it is attached to a persistent volume, that persistent volume will be there in the node, in the AKS node, right? And from where the persistent volume is coming? From the Azure, okay, as an Azure Disk or Azure File or Azure Blob Storage. So lifespan, like I said, it is independent of the pods that use them. We have two kinds of persistent volumes. One is static and another one is dynamic. So mostly dynamic persistent volumes are used. Why? Because in static, if you are using static persistent volume, then you will have to create chunks of volumes, right? Like 10 gigs, 20 gigs, 30 gigs. You will have to create them manually. Okay. And if a person is requesting that storage, it will get assigned. But in dynamic, you don't have to create those chunks. It will, whatever you ask, that particular the whatever storage you ask, the persistent volume will provide you that, okay, without creating any chunks. So basically, in live environment, dynamic persistent volumes are being used. So as it suggests, it allows you to request storage resources on demand. Okay. Now persistent volume claim. Now how will you claim that? How will you attach it to the pod? So by using persistent volume claim, it to consume a persistent volume, pod needs to create a persistent volume claim, which is a request for storage resource. Okay. So it basically, it is a channel between pods and the underlying storage, allowing pods to consume storage resources without directly specifying the detail of underlying volumes. Okay. So first, when you are using a dynamic persistent volume type, you don't have to specify anywhere that you are using dynamic. You just need to create a persistent volume claim and provide the capacity, provide the storage over there. Like you, if you want 5 gigs, then you will just create persistent volume claim, and you will specify that you need 5 gigs, and it will automatically create a persistent volume. Okay. And that is one of the benefits of using dynamic persistent volume as well. Okay. So yeah, when a PVC is created, Kubernetes matches it with an available persistent volume that specifies the requested criteria. So as we are using dynamic persistent volume, so uh, it will automatically create that persistent volume. You don't have to create another persistent volume, chunks of volumes over there. Okay. So if you see the lifespan of it, so first, right, so first, Azure Managed Disk or Azure Files. So once a persistent volume claim is created here, from where it will get created? It will get created from the storage class. So in the storage class only, you will mention which kind of volume you want. You want Azure Disk, Azure Files, or Blob Storage. You will specify in the storage class YAML. Okay. So once you create a persistent volume claim, it will you will specify the storage class over there, storage class name. It will go to the storage class name. It will check for the type of volume. So if it will see that it is using Azure Disk, then it will create a persistent volume. From where? From the Azure Disk. It will create a persistent volume automatically from the Azure Disk. Okay. And that particular persistent volume claim will get binded to pod. Okay. So that's how it works. You see the YAML of it. Just a minute. Yeah, sorry. Yeah. So if we will see the YAML of it, first storage class is getting created. Okay. Then storage class, you provide the name of the storage class. Then here provisioner, in the provisioner field, you will provide the name of the type of the volume that you want. Okay. And then after that, you will create a persistent volume claim. Okay. So you will provide the name there, and then the request here, you will provide 10 gigs if you want 10 gigs, and you will provide the storage class name over there. So what it will do, it will directly go to the storage class. It will check for the Azure Disk. and it will create 10 gigs of persistent volume. Okay, and then you will ultimately you will create a pod, and you will specify the persistent volume claim name over there in the volume section. Okay, let's understand the life cycle of it, life cycle of the persistent volume claim. So what, how, from where it goes, and how is the life cycle of the persistent volume claim works. So the life cycle is like that. It, first of all, it will go to the bind state. Okay, so in that state it will try to bind that persistent volume claim to the persistent volume. Okay, so when you create a persistent volume claim and when you apply this YAML, it will also create a persistent volume. Okay, so it will also create a persistent volume. So once it is bounded to the persistent volume, it will say that, hey, we have that 10 gigs. It will also create that 10 gigs in the Azure. Okay, and it will be in the bound state. Then it will attach that persistent volume claim to the pod, and it will be available to use. So now we are using that persistent volume claim, okay, in the pod. Once we are using it and once we are done with it, we can delete it. Okay, we can delete it manually. So there is one catch as well. So if you delete it, what happens? Okay, so there are two things. If you will see the storage class YAML, here we have the reclaim policy. So how many types of reclaim policies are there? Two types. One is retain and another one is delete. So once you delete the persistent volume claim and you have provided the reclaim policy as retain, then that persistent volume will not be deleted. Okay, that underlying storage will not be deleted. It will be available to reuse. So if you want your data to be intact for a long time of period, you will be using a retain reclaim policy for that. Okay, now the second one is delete. So what will happen? That will delete that persistent volume. So if you won't require that particular uh, piece of volume to be there in your cluster for a long time, and you can dump it, you don't have any issues with that, you need to use a reclaim policy as delete for that. Okay, one more thing, when you are using Azure Disk, you have the option to increase the uh, size of that persistent volume claim. Okay, so here you can provide that parameter of allow volume expansion to true. Okay, so what it will do, you can, if after some time you want it to increase this persistent volume claim, the same persistent volume claim, you can increase that by just editing the storage, editing the YAML and apply it. But you cannot decrease that persistent volume claim. This is not allowed, because if you go to the Azure Disk and if you will see, you cannot decrease the storage, because you in the Azure Disk, the storage are the data are present in racks. Okay, and when you decrease the size, you Azure is not completely sure which rack it will delete. Okay, so that there will be higher chance of losing the data. So that's why it is not recommended. However, we have another approach where we can use that, where we can decrease that. I have used in a live environment. I'll show you in the coming videos. Okay, so that will be it for today's video. Actually, persistent volume claims and persistent volume are very crucial in Kubernetes, because you will be using persistent volume claim for sure. Okay, and you need to know what kind of what is the background of it. So I hope I was able to provide you the background of persistent volume and storage in Kubernetes. Please, if you thanks for your timing, and if you want to know more about AKS, please subscribe to our channel.